Hello, I'm David Matos, and this is the Joy of Why, a podcast for Quantum Magazine that takes you into some of the biggest unanswered questions in math or science today. In this episode, we're going to be talking about what it means to be alive. What is life? Can you define it? Science don't actually agree on a definition. It sounds weird, right? I mean, most of us would say with some confidence that beer is alive and share is not. But going deeper, science asks questions like this. To be considered alive, does something have to be able to reproduce? Does it have to be a product of evolution through natural selection? Does it need to have a metabolism and be able to process energy? Any definition along these lines is riddled with exceptions. For instance, is a virus alive? Well, viruses do evolve, but they don't replicate on their own. They use the host cellular machinery to make more copies of themselves. The question of what life is also matters. Because if we're going to be looking for life in other planets, don't we need to at least have some idea of what we're looking for? Later on in this episode, we'll hear from Sherry Mansey, professor of chemistry in the Department of Chemistry at the University of Alberta. But first, joining me now is Robin Hastings. He's a mineralogist, astrobiologist, and senior staff science on the Carnegie Institution Air and Planets Laboratory. Bob, thanks so much for joining us today. Oh, it's a pleasure. Thanks so much, Steve. Great. Well, let's jump right into this. Why is what is it so hard for science to agree on something that common sensically most people would say they already understand? Like we know that a plant is alive and a rock is not. Why why is it so hard to come to some agreement about the definition of life? Yeah, that seems strange, doesn't doesn't it? Because we all know things that are alive, and we all know things that aren't alive, and yet it's a gray area in between. So when we start saying this is alive and this is dead, that's fine. But when you say everything either has to be alive or dead, you are setting up a you are setting up a false dichotomy, because the taxonomy of what it means to be alive, I think, is much richer than just dead or life alive. How so? Well, think about it. You have an origin of life, so that's a really good metric. There was a point in our Earth's history where there wasn't a single living thing. It was a blasted surface. It was covered with volcanoes and magma, and it was just basically inhospitable. There was no place that life could even get a tiny foothold, but gradually, as the air cooled, as ocean formed, as the atmosphere became more palatable for some kind of living thing, within there was a process, a historical process, the origin of life, in which chemical system became gradually more complex, became more interesting, and at some point, yes, there was a first cell that probably had proteins and DNA, but there had to be something before that. And where do you draw the line? It's just difficult to say there's an absolute point in space and time when there was no life, and then the next point in space and time there was. Interesting. So, the way you are phrasing it, it sounds like it's an issue of chemical complexity or something like that. It's a question of chemical complexity, but it's also a much more basic question of taxonomy. You know, it's so easy for humans to think in dichotomies, good, bad, black, white, day, night. These are things that make life simple. It means we can categorize things very, very quickly. And early on in human history, this was the defense mechanism because you had to make the decision very, very quickly. Whether you know we're going to shake the person's hand or shoot an arrow at them. So we needed to make this decision. But we don't have to do that when we're thinking about the larger issues of the natural world. The natural world is amazingly intricate and complex. And how those chemical complex systems emerge and at what point a complex chemical system is something that we can alive. It's not all obvious. So I get your point about the gray zone. I mean, it's black or white is usually too simple. Apply it to practically anything. That there's always some ambiguity in between. Nevertheless, let's say in the case of a space mission the NASA's running, maybe off in the future we'll be trying, or even with earlier mission, we will send proofs to Mars and the kind of thing that were a quest to see if we could detect life. And so, you would think in order to address the question objectively, you had to have some criteria for what you mean by have you found it or not. And NASA did have a criteria, and mostly it has to do with what I would call chemical idiosyncrasies. So, organic molecules made with a carbon backbone are everywhere in the cosmos. Anywhere there's carbon, you get this thing called organic chemistry. Lots of different kinds of molecules. They use sort of jumble a mash of the things form. But life is very, very particular. And one thing I think we can say is if something is alive, it's going to put its energy into making a few molecules that work really well and ignoring the vast number of molecules cure that don't do much of anything. So if you have a system that has the biological overprint, it's going to show very specific groups of molecules, maybe molecules that are what called chiral or left and right-handed. Maybe you have a predominance of just the left-handed or just the right-handed molecule. Maybe you have just strings of carbon that had multiples of 2 to 4, 6, 8, rather than all the other odd numbers as well. Maybe you have some other characteristic that wouldn't form just by a random process, but forms by a selective process. So that's what NASA was looking for. I and I think that's a smart thing to do. That's very interesting. The idea of chemical selective to say could could be or at least what's proposed by NASA to be a possible. Well, nowadays we speak of biosignature. I don't know if you that we would be the language that they will have used and the time. Yeah, exactly right. That you're looking for biosignatures. So I think if you see those chemical idiosyncrasies, you can say, "Wow, something really interesting happening here." And it doesn't look like just the normal natural process. Looks like there was some real selection for function. Molecules that did a job, they metabolize or they help build a strong cellular structure or something like that. So I think that's what they were looking for. But the fact of the matter is that doesn't define life, does it? It just say we're looking for something that we think is characteristic of the kind of life that we're familiar with. How many other kinds of life may there be out there? And that's something we just don't know. We don't have enough information to build a taxonomy to say these things are alive and these things are dead and these things have some other interesting chemical features to maybe lifelike but don't quite get us there. What would be some others then besides functional? There's chemical systems that may be able to make exact copies of themselves, but they wouldn't undergo mutation and natural selection. There are chemical systems that may template themselves, so they grow laterally, and they get larger and larger, and they tend to grow, but they don't really have this characteristic of encapsulating and separate entity that we think of as being life, lifelike. But they are interesting systems, and they are part of a kind of continuum of chemical complexity. And to me, the much more interesting challenge is to develop this taxonomy. Now, think about the linear classification system, where you had the kingdoms or below the kingdoms, you had phyla, and you have orders and so forth. Well, well, maybe in our taxonomy of chemical complexity, with a kingdom of no living things, and the kingdom of living things, and we have a kingdom of ambiguous things, and then beneath that, we had a whole bunch of other subcategories and subtypes, and we've been realizing that the universe is an amazing and wonderful place, and that chemistry that just extraordinary things, some of which we call life.